everybody, welcome to the 6th grade podcast. We're going to talk to you guys today about heat transfer and how wind is formed.
So we have three kinds of heat transfer. The first kind is radiation. That's the transfer of heat in the form of electromagnetic waves such as sunlight. This could also be anything on the electromagnetic spectrum, so microwaves, radio waves. Second type is conduction, and this is the heat transfer through two objects touching. So like the picture somebody holding that nice warm cup of hot chocolate, or air touching land or water, or you hugging somebody really warm when it's cold outside. And the third kind is convection. That's the flow of heat in gases and liquids. Warm air rises, cool air sinks. Remember, we talked about this when we talked about deep ocean currents, and so you should be really familiar with convection. Don't forget about our 2 experiments before Thanksgiving break and how the hot air made things rise.
All right, so the easy way that we remember what radiation is, well, radiation comes from the sun's rays. So radiation, sun rays. Conduction, there's a couple of ways that you can remember conduction. The D and the C means direct contact in conduction, or you can just simply memorize it. Another way that you can remember it is conduction has the word duck in it. And so when you think about a duck, go quack, 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 and its bill's touching. So you can go quack, quack. Well, your fingers are going to touch, so you can help you remember that conduction is through touch. And then convection, you can remember convection is like conveyor belt. Convection, convection. It circulates the air around like a conveyor belt, like what you would see like at the Krispy Kreme factory where the donuts are rolling down. Well, that's a conveyor belt where it's bringing in those hot, warm, delicious donuts, and then it's going to go around and pick up some more donuts. All right, so that leads us to wind. Now, wind is formed through pressure differences that's caused by uneven heating of the Earth's surface. So the big takeaway picture here, if you notice on the picture, the diagram here, we've got the distance between the sun and the Earth at the equator. Well, that's much shorter than the distance between the sun and the Earth at the poles. So what happens is it takes longer for the sunlight to reach the poles, so it's a little bit colder. Plus, it's going at an angle, so it's not going to be as strong at the poles instead of that direct sunlight that we have here at the equator. So it's much warmer here at the equator than it is at either the North or the South Pole. Well, you should know that from 2nd grade. You should remember that, okay? But the 6th grade application that we want you to remember is that high and low pressure. Remember, high pressure is heavy pressure. It sinks down. Well, what temperature sinks down? Cold does. Plus, it's cold at the poles. Okay, so that's cold up there. So that means high pressure. So we're going to have some high pressure systems at both of the poles. Well, the equator is very warm. Well, what does warm air do? Well, warm air rises, and that pressure system that allows warm air to rise is low pressure. So at the equator, we're going to find low pressure. So what happens is we have that high and low pressure interacting with each other that creates the push or the wind that we would feel here on the surface. And that all goes back to convection. So convection is how air creates pressure differences. Now, warm air, which is going up or down, Ms. Butterfield?
It's going up. It's rising air.
So rising air, which is warm air, leaves the surface creating what kind of pressure?
Low pressure.
Low pressure, because low pressure allows warm air to go up. Now, what is cool air? Is that sinking air, low air, high?
It's sinking air.
Sinking air. So sinking air is cool air, falls through the earth, creating
high pressure.
High pressure. So that high pressure, heavy pressure brings down cold air. And now we got to remember that wind moves from
high to low pressure.
High to low pressure.
All right, so let's put all that together. Let's start with high pressure. Remember, on the weather maps, we see high pressure is a big blue H. That's some cold air. And cold air is more dense, so it sinks. And we also learned that air goes from high pressure to low pressure. So over here, we have some low pressure. And low pressure air is warmer, and it's going to rise. Now, when it gets up here in the atmosphere, higher up, it's colder. So that air is going to cool off and head back over here to the cooler air. So down here, this is the ground. We have a little guy down here. He's gonna fly. Okay. And up here we have the atmosphere. Well, what you're gonna feel is this air moving from high pressure to low pressure. We call that wind.
Okay, so those are winds that are occurring all around the world. A lot of that includes global winds as well. Now, when we look at a much smaller scale, maybe down here, in our backyards, we're going to be talking about local winds. Those local winds are land breezes and sea breezes. So let's talk about a sea breeze first. So I like to draw, so we're going to draw another picture. We have our water here, and then we've got our beach. All right, and so what happens is that we've got this sea breeze that's coming from the sea. So I like to remember that a sea breeze is from the sea, so the wind is blowing from the sea. So this is the wind here. And really, I just like to play connect the dots. Now wind, when it's down here on the ground, it likes to warm up. The ground's going to be much warmer than the atmosphere. So when that wind that we're feeling is on the ground, it's going to warm up. So along its path, it's warming, it's warming, it's warming. And eventually that warm wind is going to get so warm that it's going to want to rise. And remember, warm air rises in low pressure systems. Once that air rises, it cools, it condenses, cools down. And we know that cool air or cold air likes to drop. And what pushes that cold air down is that blue high pressure. All right? Now, a couple more things that you need to remember. A sea breeze will happen during the day. Okay, so we've got our sun over here. It happens during the day. Don't forget that. That's important. Why is that important? That's important because the land, the ground over here, likes to warm up faster than the water next to it. Land will absorb more heat, so it's going to be much warmer during the day than the water. The water won't heat up as fast as the land will, which brings us to a sea breeze. Which brings us to a land breeze. Now, a land breeze, look at the picture difference. We see that it's happening at night. Okay, so we're going to have our little moon up here, a little crescent-shaped moon. It's going to happen at night. Why does this happen at night? All right, well, same thing that caused the land to warm up during the day. Well, the sun's not there to warm up the land. So what happens with the land? Well, the land gets much, much colder now. So if it's colder on the land, we're going to have that cold air drop over the land, which is, again, that high pressure system. When it drops on the land, remember, high to low is where our wind is. So it's going, plus it's a land breeze, it's going from the land. And that wind will warm up there on the ground, get warm up, warm up, warm up, until eventually it rises. What allows warm air to rise? Low pressure systems. And when it goes up into the air, into the atmosphere, it's going to cool down and then drop back down over the high pressure.
Study, study, study. You have fabulous notes. You've made some videos. You have this video. Don't forget to check on Canvas for a few videos on wind. And good luck on your quiz.